Okay, all right, cool. So we have the recording started now, and let's get started. It's 11:46. All right, so thanks again, everyone, for joining on a Saturday afternoon. And for some people, it's pretty late at night. Stalin, I really love your enthusiasm. Thanks for joining in. And for anybody else, it's like staying up very late at night. And that is the core purpose of this group, to make sure that each time we come in, there is hands-on learning that we could take from it, and use it in our day-to-day work. So keeping that theme in mind, today's topic or discussion or theme is about on reproducible machine learning. Now, this topic becomes very important because there's a lot of things which are happening or happen in the ML community, and often people have a hard time in taking ideas into production. So a lot of things starts with an experiment and dies with an experiment because a lot of people are not able to reproduce it. So how do we come around that problem? And so we have on that topic, it's a very broad topic. And so we have two awesome guest speakers with us today. And so today's session, we're going to have two talks. Um, so first talk is by Milecia McGregor, and the topic is on reproducible experiments with Git and DVC. Um, one quick request. So now that we are starting the discussion, if we are not speaking, it would be great if we mute our microphones. That way, we won't have uh, you know chatter. Okay, thanks, guys. Appreciate it. Cool. All right. So Um, Milecia is a software engineer at DVC. She's an international tech speaker as well. Milecia, as a part of your talk or wherever, if you can share the links where people can go and check out some of your other talks, that would be awesome. I think they're really great. She has worked extensively in hardware and software side of things. She's passionate about JavaScript, and one thing which really caught my attention, and I would like to learn more if you have videos of that. She is also a unicyclist, or she likes to ride that, and she likes playing with dogs and with her dog. Um, and so with that, over to you, Militia, and if you would like to introduce the topic and just take it over from there.
All right, sounds good. So I'm gonna go ahead and share my screen, maybe. Oh, of course, there's something else. I have a feeling that I'm about to get kicked off of Zoom because it asked for more permissions.
Sorry.
But let me see. Hopefully not. Okay, I will be right back because MacBooks like to restart things to give you more permissions.
No problem. No problem. No problem. All right. So as she's restarting her laptop, so a little bit about DVC. Or maybe about the workshop is so in this workshop, the goal or the agenda would be to learn about open source tool DVC and how it could be used for keeping track of ML metrics, comparing them, comparing hyperparameters, keeping track of it. And as we do all of these experiments, there's often an issue around data versioning, code. How do we maintain history of it? Because the core motivation for all of these experiments is that we want to make use of it, hopefully in production, to drive a use case. And if we are not able to go back to it, we're not able to reproduce it, then we start to lose all our vital time that got spent. And here, yeah, Milecia, you're back. Over to you.
Yeah. Thankfully, that didn't take a really long time.
Oh no.
But yeah, so hey, everybody. My name is Milecia McGregor, and today I'll be talking to you about tuning hyperparameters with DVC experiments. You can reach out to me with questions or comments on Twitter at Flipped Coding, or you can reach out to the DVC team on Twitter at dvc.org. But I want to give you a little background about myself first. And I have my master's in mechanical and aerospace engineering. I worked as a roboticist slash machine learning engineer for a while, where I helped build some software and hardware to go on board autonomous vehicles. And the software part was trying to figure out how to get this crazy feedback loop between the car, passengers, and pedestrians to just help, I don't know, make people feel more safe in autonomous vehicles. But after that, I've been doing all kinds of other software development. I've worked on the Mozilla VPN. I've done web development all across the stack, front end, back end, DevOps, database admin stuff, mobile apps. If it touches the web, I have probably dabbled in it just a little bit. And I'm a developer advocate at Iterative, where I focus on DVC now. So just all over the place. But today, we're going to talk about those hyperparameters. And at the beginning of all of my talks, I like to give a quick overview so you know which sections you really want to tune into and which ones you probably already have a little background about. But it sounds like we have a good mix of people who are new to machine learning and people who have already been doing it for a while. So that's a good crowd. But to get started, we'll go over a little background on tuning hyperparameters and why we do that. We'll jump into using DVC and also why you would want to bother doing that. And we'll talk about a couple of hyperparameter tuning methods, but we'll start with grid search. And I'm going to attempt to do some live coding today. I checked this before I joined the Zoom call, so hopefully everything still works. And then we'll talk briefly about random search. We aren't going to implement it today just because it's a little bit more complex. And finally, I'll wrap up with a few key takeaways and just a couple things that I really hope you get out of this talk. So to start with, let's talk about tuning hyperparameters. So hyperparameters are the parameters that define your model. This is different from your model parameters, which you get from training with your data. But hyperparameters basically define your machine learning model. So they answer questions like, what degree of polynomial features should you use for your linear model, or how many trees should you include in your random forest, or maybe how many layers you should have in your neural network. This is what the hyperparameters of your model define. And this process, which we call hyperparameter tuning, is basically how you find your ideal model. It's a very iterative, it's a very iterative process where you have a set of values that you want to try on your different hyperparameters, and you cycle through them until you find something that matches what you need. So again, I want to stress that these are not the parameters that you get from training with your data. Those are called the model parameters, and they're learned during training when you're optimizing a function, a loss function, like, I don't know, using something like gradient descent. But the process for learning hyperparameters is basically just a bunch of educated guesses until your model gives you some results that you find are adequate. But a little bit more about hyperparameters is that once you find a set of values you want to iterate through, you really need a way to figure out how you should update your hyperparameters, right? And this process generally means you define some kind of model, you set a range for all of the hyperparameters, and you go through some method of sampling those values. Then you use some kind of evaluation criteria to judge your model, and maybe, hopefully, you have time to do some cross-validation. But we're focusing on a method for sampling those values. And that's where DVC comes in. So usually when you're doing hyperparameter tuning, it's a lot of just experimentation. So you might make code changes, you might update hyperparameter values, or maybe you're doing some of that model validation and you change your data. So the thing about that is a lot of times we stumble across some really good like model optimizations, but without those changes being tracked, it's hard to go back and figure out what exactly made this huge difference in our model's performance. So with DVC, the focus is on reproducibility. That's most of what you'll hear me talk about in this talk, is just how important reproducibility is. And using a tool like this, it makes hyperparameter tuning so reproducible that you have an ID associated with each experiment, and every experiment is basically like self-contained. It has all of the code, the hyperparameter values, and the data for that particular experiment run for your tuning. And reproducibility like this just makes it safer for machine learning engineers to play around with different values, to make changes to the code. And if another person on the team comes along and they're like, hey, which values did you use? Or maybe a completely new person comes along and they're like, well, I'm not sure how you run experiments or which values I should start with. They can all take a look at this backlog of experiments and all of those tiny changes that go along with them. So when you have reproducibility like this, it just makes it more efficient for you to find those optimum values faster because you're able to track those differences over time. So maybe a month from now, I don't know, maybe the project gets shelved and a month from now you come back and you have no clue what you were doing. You can just go back, look at the experiments table and get a good idea of where to start again. But with that being said, let's talk about one of the hyperparameter tuning methods, which is grid search. This is one of the most common methods for hyperparameter tuning, and you basically just select a set of reasonable values for each hyperparameter. So say you have 3 or 4 different hyperparameters, you would have a set of values for each of those. And this does an exhaustive search over all of the values. So you can imagine if you have a lot of hyperparameters and you have a lot of values associated with each hyperparameter, tuning can take a pretty decent amount of time. Maybe it's a little resource intensive. It, it just covers a lot of area, but any values you give it, it will iterate through. So with that being said, let's see if my code will continue to work. I'm gonna switch over here to VS Code and kind of introduce you to this project. This is just a little NLP project. It's nothing too complicated, and I'm not gonna spend a lot of time talking about that training because I wanna show you how reproducibility helps with everything. But this is what it would be like if you were setting up a DVC pipeline for the first time. You would go into your project directory and you would run DVC init. And this command will create this .dvc folder up here. This holds all of the configs you need to run DVC, and you don't have to worry about it once it's there. Your pipeline is already ready to accept commands or accept new stages to run. And to add a stage, you'll run another command called DVC stage add with a -- name flag, and this will be your training stage. And then we'll add a dependency, which will just be our training script, which you can see in the source here. It's just this train.py. And then you probably add some stuff about how you want to handle plots and data being stored, like which file directory. But once you run this command, inside this DVC YAML file over here, it generates this stage. So this is where all of our training happens. If you notice, we have the Python script that gets run up here, has a couple of dependencies. And one really important thing I want you to note are these params. So in a lot of machine learning projects, when you want to tune hyperparameters, all of the parameters for everything are just in one giant config file. And if you change one little thing, it triggers all of your scripts to run again, even if you only just need one or two to run. But with something like DVC, you're able to granularly choose which stages you want to run. So if we update any of the parameters in here, the train script is the only thing that'll get run. We won't need to refetch data. We won't need to reprocess everything. It'll just start straight from training. So let's take a look at this params.yaml. This is where we hold all of the parameters, all of the hyperparameters for each of the stages, but we're focused on the train stage. And you see these correspond to what we have over in this DVC YAML. So anytime we change a value here, it's going to trigger this script to be run. So I'm going to clear out the terminal because that looked weird. And we'll just run an experiment with an NEST of, I don't know, 175. And any values that I pick during this session, they're just random values. Just so you know, there's no real reason or rhyme behind them. I just want y'all to see how cool this is. But now that we've updated a parameter, we'll run a new experiment using DVC exp run. Oh, what in the world? Really? It would act up right now. This ran just a second ago and now it wants to do something weird. So let me look in here. See, DVC YAML failed to run this script. Just gonna try to get rid of that and see if that does it for us. You know, every time there is live code, something will go wrong. Let me see if that does it this time. Oh my gosh, the training script doesn't want to work. Wow. You're right. I do need an environment. It is those little things. Thank you. So let me do that. Activate the environment. There we go. Now I'm gonna undo whatever it was that I just changed. And now DVC exp run will work. Yes, Whoever said that about the environment, thank you. I always forget to do that for some reason. But now that we have this script running, it's gonna go through and train and report back with a certain precision that we can look at with, I'll clear the terminal here. So once you run an experiment, you can see every experiment that you run in your current workspace with DVC EXP show. And it brings up a table with all of the experiments that you have run. And it can be a little bit overwhelming. So what I'm gonna do is make this table just a little bit easier to read. So we're still using DVC EXP show, but this time I'm just going to include these two hyperparameters here so the table's easier to read. So we'll run include params train dot nest and train dot min split. Okay, that is way better. So you can see our most recent experiment here because it has that NEST value we updated. The average precision actually isn't that bad, 57.6%, but I'm sure we can do better, which you can kind of see down here. But yeah, I'm gonna try to not answer the chat right now, but I will be around for questions right after this, I promise. But now that you've seen how these experiments work, you saw how easy it was to update that hyperparameter, and we have all of the values associated with it. So let's say, for example, you wanted to automate this. You want to do a grid search just with some Python script. The way that you would do that with DVC is actually with one of our cool features, and that is queues. So you can queue up different experimental runs and not run them as soon as you write them. You have time to think about whether you want to change your hyperparameter values, or if you want to run things in parallel, or if you want to handle them across different resources. You're able to do that with these queues. So to create a queue, you'll run DVC exp run, and we'll use this dash dash queue flag. And then we'll use another dash dash to set a param. And let's set the min split this time. So let's set this to a value of, let's say 70. All right. And you see that this was queued for a future experiment. I'm gonna go ahead and run a couple of these and just get them queued up. So I'm just hitting up arrow in the terminal. And this is just making a couple experiments for us. All right, so now we have our experiments queued up. When you're ready to run them all, you'll just do DVC exp run and use the dash dash all flag, run all flag. And what this is going to do is execute that train script for each of these hyperparameter values. And we can take a look at what our average precision is with each of those experiments. So while this is training, do I have time to look at the chat? Yes, you can actually run this in parallel. So it's an experimental feature right now, but we have a, let me show you on this new command. So we have, when you run all of the experiments in your queue, if you want to run things in parallel, remember, this is an experimental feature, but you can add the dash dash jobs flag, and then 2. That'll run 2 experiments in parallel, or you can run multiple. So it's just whatever your project needs. But now that we've run those queued experiments, let's take a look at that table again. Oh, well, let me give you the one that's cleaned up. So I'll clear this and we'll run DVC exp show. And I'll just include those couple of parameters again. Okay, that makes it easier to see. And these are our current experiment runs. So you'll see when we first started, we had a min split of 64, and our accuracy was pretty good, 57.6%. We see that once we hit 70s, it seems like it goes down. So we know we probably don't want to increase our min split. But I want to show you what this would look like if you actually made a script to run your experiments for you, or to at least create the queues for you. So I made this little train tuning script, and all it does is basically automate that for you. You have the command up here just in case you need a quick reminder of what you need to run. And then we just use subprocess.run to execute all of these queue commands. But you'll see we have our different values. It's just an array of different hyperparameter values. And we set up this run process. So if I were to execute this, I'll do Python 3, and I'll go in the source tuning.py. You'll notice it's creating all of these nicely queued experiments for us. And if you wanted to, I didn't automate this part where you actually run all the experiments because you might want to do that manually for a lot of different reasons. But all of those queued experiments are there now. And I'm going to prove it to you in this table. So it's going to be all, oh, wrong button. So DVC exp show. Then I'm going to hit enter a few times, and you'll notice we have all of these experiments with the asterisks next to it. So these are our queued experiments, and this is what will handle our grid search for us. So I'll quit that. And again, since we have all those experiments queued, we can just do DVC exp run -- run all. And it is executing all of those different scenarios for us. So this is just one of the ways that you can execute grid search with DVC and have some reproducibility behind it, which I'm going to show you as soon as these are done. Because with reproducibility, that means you can compare metrics across experiments. Ooh, which is actually really cool. You can track your performance over time pretty easily. Let me see if there's anything in the chat. Yeah, you could do this with one for loop if you wanted to. There's no particular reason I made it with 2, but totally. Can you export the table? I don't think we have that as a feature yet. Right now you can copy and paste the table, but I don't think you can export yet. A new PR is right. I guess that did queue up quite a few experiments. What is that, 12? Oh, so you can export. We just need to use the -- show JSON option. It's always something fun and new to learn about DVC. All right, all of our cues are finally done. So you've already seen the table plenty of times, but I'm going to show it to you one more time, just so we can get to cooler things. Oh, let me show that cleaned up view. Let's see, back up here. Okay, so these are all of the experiments we just ran, and let's take a look at some of the best and worst average precision values. It looks like this experiment has one of the higher average precisions. So I'm going to copy that ID, and then I'm going to paste it up here so that I don't forget it. And then it looks like this experiment did not have that great of a average precision. So we're going to take a look at the difference between these two. And to do that, we'll start with DVC Metrics diff. And I'm going to paste in the older experiment ID first, and then paste in the more recent one second. So this just brings up a quick comparison of the stats between two experiments. And what you're seeing here with the old value is what ID you put in first, and the new value is associated with the ID you put in second. But you can see the difference in the average precision here. We got like over a 3% increase in precision. That's incredible. Like some teams might take a year to get a 1% increase. And we just did that in what, maybe 5-7 minutes? So that's the power of reproducibility. You're able to see these kind of changes and know exactly what changed to make these differences. And then I want to show you what these look like with plots. So I'm going to cheat a little bit here and just edit this last command to be DVC plots diff with those same two IDs. And this generates this plots.html file here. And if I go to the browser, these are those experiments we compared. So the older experiment is the blue line, and the new one is the orange line. And you can just see how those precisions are so very different. But if you needed to make something for like a visual report, or you want to show the business side of everything, how great your work is and how much you're going to generate in value with all of this training you've been doing, this is a good way to show it. Let me take a look at the chat real quick. Huh. No, we aren't able to sort, but that is a good feature request. Thank you. So now that you've seen how we deal with experiments, how we queue things up, how we take a look at different metrics and different plots, there's one more tool that I'd like to show you that is directly related to this. So let's say you wanted to make a code change here. I'm gonna add a max depth to this random forest classifier. And this number may or may not make sense, but I'm just going to put in 10 here. And say we wanted to run one more experiment. With reproducibility being the main focus here, we actually have a snapshot of this experiment with this code change in particular. Like we know we didn't update any of the hyperparameters. So let's take a look at how that code change affected our average precision. And you see changing that random forest classifier to have that max depth, it lowered the average precision. But the main thing to note here is we know exactly what change caused this difference. So if you were just at your computer experimenting with different values or making changes to your code, now you have a snapshot of every little change you've made. So you don't have to guess, did I change a hyperparameter that time? Did I change the code? What happened to give me this different value? This takes all of that guesswork away from you because of these IDs over here and all of the data you have associated with each experiment run. But there's another way that you can do this. We have DVC Studio, which is a new tool for us, but it's connected directly to your GitHub repo. And if you have everything set up for DVC and CML, which I'm not going to talk about, I just want to show you the hyperparameter tuning. You can go to any previous commit that you've made, and you can run a new experiment just here in the browser. So if you have a big machine learning team and some people don't quite understand the code side of things, they just want to be able to update values, this is a good way to give them access to do that. So for example, say you wanted to change the min split here to 32 or something. You just make that change here, and this actually creates a new pull request for you in GitHub, which tracks this change for you. So you can commit that change, and it starts the training process over again right here in the browser, and it'll print out all of your values associated with it. So that average precision again. But just wanted to make sure you all know about this. You can keep up with this on, what is it, studio.iterative.ai, and check that out. But that was it with this part. So now that you've seen how to handle tracking hyperparameter changes, how tracking code changes helps you figure out what you need to try next, let's jump back to the presentation and talk a little bit about what other methods you could use inside DVC. So the second most commonly used hyperparameter tuning method is random search. And it's got some similarities with grid search, but the main difference is that instead of going through each value for each parameter individually or even paired together, this just jumps around all of the values that you give it. So maybe your min split gets set to 32 and your NEST gets set to 250 at the same time, and you get to see how those values just affect your model a lot faster because you're not going linearly in a grid. But random search can outperform grid search when there's a small number of hyperparameters that really make a difference for your model's performance. So if you have 4 or 5 hyperparameters, maybe only 2 of them actually have a significant impact on your model. Random search will probably find that faster than grid search would. But this is better for lower dimensional data just because you want to keep some kind of bounds on how much random search is jumping around. So if you have just a lot of different values and hyperparameters all paired together, it probably, there's a chance that it just might be slower. It might find your optimum and it might not. With grid search, you'll end up with something that's at least okay. Random search, you can end up with something that's way better, but it just might take longer to get there because you're jumping all over the place randomly. So We can talk a little bit about how you would implement that in DVC, but we're not going to get too deep into the code part. But basically, you could have another script similar to this that uses some kind of, I don't know, Bayesian approach or a Gaussian approach, and you pick random numbers from a distribution, and then you plug those in here. So it might not be as complicated as it seems, depending on how math intensive you want to get into generating those values. But with that being said, it's about that time to start wrapping up. Just have a few key takeaways for you. So tuning hyperparameters as fast as you can and as efficiently as you can will make your model better. There's no doubt or question about that. But the main thing to keep in mind is that this is a very iterative process. And the thing that you want to keep in mind is since you are doing all of these different iterations, you want them to be able to be reproducible. That way you can still just keep an eye on those important values that are changing, or maybe you decide you want to try out a completely different algorithm to set your model up after. When you have reproducibility, it doesn't really matter what you decide to try because you can always go back. And without reproducibility there, it really can leave you in a place where you have this great model, but you have no idea what you did to get it. And that, I mean, once the model's out there and you don't know what you did to get it, maybe you start having some drift between staging and production, and you're not sure what the difference is, or maybe there's something else going on and some engineer came and changed the code and now that's what's in production, but you don't necessarily know if that's all they changed. So when you have reproducibility as part of your machine learning process, it just gives you that added bit of security that hopefully you can't mess up this hyperparameter tuning, and you can recreate your model whenever you need to from any point you need to. And then this is just a personal favorite, so don't be afraid to try new tools. Tools are your friends. You don't have to do all of the hard, complicated math anymore. So why would you want to do, I don't know, some kind of weird manual reproducibility scheme, or just take a chance on new tools. You'll be surprised at the quality of things that are out there that we just either don't know about or we don't give it a proper chance. But again, my name is Milecia McGregor. You can reach out to me with questions on Twitter at Flipped Coding, or you can reach out to me and the entire DVC team on Twitter at dvc.org. But yeah, I'll be here to answer any questions that y'all have.
Awesome, Alicia. That was very, very, very thoughtful and well narrated presentation and a workshop. Um, one follow-up question I have is, what would be a good way for people to contribute to the open source project? Is there a program or is there a path that you would like people who might be interested to come and work on some of
Yes,
the interesting ideas that you guys might have?
I do have a link. So I'm going to post a link to our GitHub repo. If I can find Zoom again. And you're free to open up issues here. You're free to ask questions. We also have a Discord channel or server. Let me see if I can get the link to that really fast. And then again, there's the dvc.org page where you can check out all of our docs. We have a lot of different ways you can get involved if you want to be involved. And then here's the link to that Discord, just in case you want to hop in there and say hi. We have a bunch of questions that come through there a lot, and we do our best to answer them as quickly as we can. So even if you're working on something for work or a personal project or a school project, we're pretty friendly with answering questions you have.
Great, great. Others, any more questions for Milecia here?
Yeah, I have one. So the work that I'm doing with my friend in machine learning for bioinformatics really corresponds to what you guys are doing with DVC. And one of the questions I'm trying to unravel, because I just don't actually know how they're, the business cycle of commercial biopharmacology runs, is it seems to me like these drugs get made somehow, and it's not because a data scientist pulled a rabbit out of a hat. I'm guessing that they know their data is inadequate, and the role of the data science team is to figure out what clues are missing to solve the mystery, and then they do an experiment to find the clues. And it seems from the data scientists that I've talked to that there does seem to be a lot of poking and hoping and brute force. And I think that if we scaled up what you were doing with, you were talking about parallelizing it. If you did this in massive parallel and made it very configurable, then I think that it could start to unravel the mysteries of these small and sparse high dimension data sets and narrow down the search that these experts have to do. It won't give them the answer, but at least they won't have to go, through the whole old rigmarole every single time. And I really can't wait to get more involved with this. And geez, are you free sometime for me to talk to you to learn more about it? Can I bring a friend?
Yeah, we can set something up.
Yeah. I can add a little bit about healthcare and bioinformatics field. I'm also from DVC team. I supported Milecia answering question live when she was showing the demo.
He's not just on the team.
Dimitri, would you like to introduce yourself as well?
Yes.
Yeah, sure. I'm Dmitry. I'm initial creator of DVC project, and now we have the entire team. A lot of people who involved in the projects. And I was speaking on your event, right? About like 2 years ago in LA. We met personally before coronavirus, and I really enjoyed this event, and happy that we are again on the event. In bioinformatics, you mentioned like the problem of kind of reproducibility, right? To kind of try more ideas and keep track of all the ideas you have already tried. The next problem in bioinformatics and healthcare is when you got to final result, you need to like revert back and understand what actually happens, because FDIs and all other regulations company will be asking you. And again, you can like save not only time on experimentation phase, but also you can save a lot of time on the regulation phase if your project is actually reproducible and your team is kind of have all this reproducibility result.
Exactly. That's exactly why I'm getting into ML for bioinformatics. It's to get stuff to market faster, because people's lives depend on this work. We can't just sit on our laurels.
Yep, exactly. And bioinformatics is like, and healthcare is really do care about reproducibility because of this reason. Because for them, it takes like years to do this, the second phase. When the result is already on the hands, the next question is, all right, how you get the result?
Prasanna, you had a question for Milecia and Dimitri.
Yeah, I actually had a couple of questions. So one is, awesome talk, Milecia. Thanks a lot for going over this in such a smooth way. It was really nice.
Thank you.
So two things. One is, so DVC in general, first of all, I think you addressed the data version control part. So I'm just wondering, can you also monitor things like data drift and, have algorithms for data drift and then kind of measure those things on your studio or in command line aspects and stuff like that? So that was the first question. Second is, since we are talking about healthcare and other algorithms and such, so more than hyperparameters, can you also kind of integrate things like explainable architectures and how you would visualize that, understand that, and then present to a customer, for instance? So just thoughts, plans, or what you already been working on, would be great. Thanks a lot.
Yeah, so
I can take it, or Milecia, you can take it. Like it's up to you.
okay. Do you want to take it?
Yeah, I can. So you mentioned kind of higher level scenarios, how to do like data drift, how to understand data drift, and which is not like today it's not a part of DVC, and
Right.
it's probably shouldn't be part of DVC.
Okay.
Because data drift, it depends on your data. If you work with structured data, with images, with NLP, right? Data drift might have like a little bit different meaning, right? And it will require a bit different algorithms. So in DVC, we do like a very simple thing. We just like kind of track your results, track the artifacts and metrics, and then you can apply like a smarter algorithm on top of this. So what we really like to do, we'd like to integrate with the tools like this.
Okay.
This might be like a really good collaboration, and when you can kind of build your process, your workflow. This will be, this is when you get all this value. But underneath that, DVC shouldn't do this.
Right. Yeah. I guess I was trying to understand the scope of what DVC is trying to do. So so maybe. So there are existing tools and algorithms which are already implemented in like different spaces, and then DVC would help you sort of monitor all of those metrics or visualize them and so on, and then also version them, I guess.
Exactly,
cool. And so this would be the same thing with explainability, I guess.
Yes.
Is that okay. Sorry, unless somebody else has a question, I had another thought which I thought I should. So so I've been reading about in general the responsible AI space, right? So one thing which I've been interested in is this idea of a data sheet for data set, which was originally, I think there was a paper by Timnit Gebru, and this basically tells you a description of your data that you trained, and explains like, what kind of data went in, how was it trained, what was the use for it, in basically to encourage transparency in your models. The fact that you're versioning all of these data sets, I'm just wondering if there's a scope for kind of introducing this data sheet aspect to each version that is trained. Does that make sense? So data sheet will essentially be a document, like a markdown or something like that. And it kind of encourages, so the reproducibility aspect also gives you a history of, oh, this is exactly the kind of data that went in. Does that make sense for DVC? So I've not worked with DVC that much, so it's more of an exploratory question, but anyway, so thoughts?
Yeah, that's, Milecia, if you wouldn't mind, I will take it.
Okay.
So because it's like a very hot topic for us and very important. And what you're talking is it's a kind of data lineage, right? How to get track of like sources, signals, and which signals you get to the model, and what is kind of business impact to this. And DVC, it's also play a role of tools which can help you to do this. it is related to the Adam's questions on reproducibility and taking care of all these experiments and how to provide your result, explain your result for regulators, for example, right? Because they will ask actually the same questions, but from a different angle. So in DVC, again, it plays a role of like a tool which can help you to do that if you like track experiments properly, if you keep track of all the data set and signals that you use. But of course, you need to include this in your process, right? A tool helps you, but it doesn't solve the entire problem. You need to be careful in your process, when to use a tool, how to use a tool, and it's just like a building block of this process.
Okay, thank you.
Any other questions? Lane, did you have a question on file?
I was just reading about data sheets and I was like, I don't
Oh.
know, how is that going to generalize to different industries? And that's kind of like why file headers were invented in the first place, was to like indicate how to use the file and what to do with it.
Okay. Any other questions that we have for Milecia, Dimitri, or Jennifer? So one question I had was, when you will get a chance, Milecia, you'll be able to share the slides?
Yeah, no problem.
Okay, cool.
I'll email those to you right now.
Okay, cool. And then I'll post it on the meetup link as well. Cool. So if we don't have any other questions for the DVC team, then let's have a round of applause. This was a very informative session. So thank you so much, guys, for doing this. I really appreciate it.
Thanks for having
Yeah.
us.
That was perfect.
So
Thank you for inviting us again. Yeah, and thank you to Milecia.
Yeah, and really great questions today. This was a really good discussion. It was fun.
Yeah, it was.
Yes.
we got some PR.
This is what we love PyData, right?
Cool. Awesome.